All right, let's look at number 4. Again, we're back to writing formulas, okay, given the name. And again, this is a very, very common thing, going from the name to a formula or from a formula to a name. Those are basically the two directions that we can go. So we're writing the formulas here. So we got barium. What is the symbol for barium? B-A. Sounds like bingo. And then sulfide and S. But here's the thing. What charge does barium form? +2. What charge does sulfide form? -2. So they already balance each other out. I just need one of each. So I'm done. B, sodium hydroxide. Well, I know that sodium is Na. Don't we, Sarah? Yeah. Okay, but here's the thing. What's hydroxide? We're starting to get into some wacky stuff here. Here's where you guys need to make your polyatomic ion sheet a habit, okay, and a very regular thing. One of the things I'll point out, I said hydroxide. Is there an element that's named hydroxide? No. So it's probably going to be on your polyatomic ion sheet. So you guys will get used to where some common things are, for sure. But hydroxide is one of the common things. It has a polyatomic ion. It's OH. It's actually what makes an alcohol, the presence of an OH functional group. Now, it has an overall, overall -1 charge. So I'm going to slap that with the sodium. Sodium being a main group 1 metal means I only need one OH. The sodium hydroxide, NaOH. Now I'm seeing transition metal and a polyatomic ion. Again, nitrate. There's no element called nitrate, so use your polyatomic ion sheet. Lead. I'll find nitrate right here. It's NO3 with a -1 charge. NO3. Now this has a -1 charge. This lead apparently has a +2 charge, so that means I need 2 nitrates. All right, potassium permanganate. I know what potassium is. It's K. But what the heck is permanganate? Never heard of that element before. So, look. Permanganate. It's a manganese atom and then 4 oxygen atoms. MnO4. It has a -1 charge. MnO4. Permanganate has a -1 charge. Potassium has a +1 charge. You just need one of each, and you're done skis. All right, I have transition metal and a polyatomic ion, so I'll find sulfate, SO4 with a -2 charge. I'm going to have iron, SO4. Now this has a -2 charge. This iron apparently has a +2 charge, so I just need one of each. All right, one of each. I'm done. All right, different system. Notice prefixes. I have a di and a tri. Di-trying. Okay. So this is a prefix system. These are all nonmetals. Okay, I haven't even read the problem yet, and I know that they're nonmetals here. Phosphorus. Oxide. How many phosphorus atoms are there? 2. How many oxygen atoms are there? 3. Diphosphorus trioxide. Again, what tipped me onto that was prefixes. Something similar yet again. We have a di and a di. So I'm going to start with sulfur and then chloride. How many do I have? I have 2 sulfurs and 2 chlorides. Disulfur, dichloride. It doesn't have to balance because which is a good point. You don't have to balance these because these aren't ions. Remember, the reason I pointed out that these are non-metals is because they're not bonding because of electrostatic forces due to charges. These aren't charges. It's not like this is a -2 charge and this is a -1 charge, because, well, guess what? Then they definitely wouldn't balance because they're all negatives. These are bonding because they're satisfying each other's, octet rule. Okay, they're adding valence electrons together to satisfy the octet rule. But that is a good question. It's a very important observation. Carbon diselenide. Okay. Selenium is Se. Apparently there are 2 seleniums. But how many carbons are there if there's no prefix in front? 1. Okay, if there's no prefix, you're assuming 1. But you only do that on the first element. Okay, the first element that you list. If there was only 1 selenide, it'd be monoselenide. And if you ever have trouble remembering that, remember that you say carbon monoxide is the name of that. Carbon monoxide. You say the mono for the single oxide, but you don't say mono for the single carbon. Right? That's one thing that you guys will remember very well. Carbon monoxide, you guys already know that. But just reason out that name. All right. Here we go. First time acid. Now, I do not see a hydro in front of this. So that is going to cue me in that there's some sort of polyatomic ion here. Something that's going to have oxygen in there. Now, it says ic acid. Okay, ic acid is what's cluing me in. If it was an ic acid, that means it's a polyatomic ion that has an 8 at the end. So, if you guys remember from the notes, we said any polyatomic ion that has an 8 and it's turning into an acid, you remove the 8 and you add ic acid. Well, just go backwards. If this is an ic acid, it must have had an 8. So this acetic must have been acetate. So we're going to look on our polyatomic ion sheet for acetate. Boom. There it is. Now, I'm going to take this polyatomic ion, C2H3O2, right, because that's the acetate ion. Okay, this is a single unit. You don't get to split this up. But it's an acid, so I'm simply going to put the number of hydrogens in front of this ion that is equal to the charge of the polyatomic ion. You see that acetate is a -1 charge, so that means you only need 1 hydrogen to balance that out. Let's try another one. Chloric acid. Again, there's that ic. So that means that before this was an acid, this polyatomic ion right here must be chlorate. So we'll look on our sheet for chlorate. Should be the, yep, there it is. Lost it again. Chlorate. ClO3. Okay, ClO3 with a -1 charge. ClO3. It's got a -1 charge, so that means that I only need 1 hydrogen over here to balance that out. That's chloric acid. Now, this is very different. See, there's a chloric acid, or there's the one that you've heard of more, hydrochloric acid. The presence of that hydro means there are no oxygens there. It means whatever is following the hydro is monatomic. So that would be, that's the chlorine. It's just HCl. All right, K. Sulfurous acid. Now, this, muy tricky right here. Sulfurous, you might think, that's just a sulfur ion. You just have a sulfur ion with some hydrogen in front of it. That is incorrect. Anytime there is not the prefix hydro, that's going to be a polyatomic ion. There's no hydro here. So this is a polyatomic ion. Now, in the same way that ic replaces 8 in the same way, us replaces ite. Okay? So what we're going to do is we're going to look for something called sulfite. Sulfite. Do we find something called sulfite? Yes, we do. Right there. It's SO3, and it has a -2 charge. So SO3. It's got a -2 charge. So in order to balance that out, I need 2 hydrogens. So this is sulfurous acid. It's acid with a sulfite polyatomic ion. And lastly, in the same thought process, you see the phosphor? Oh, that's phosphorus. Yeah, that's just a monatomic ion. I'm just going to throw some hydrogens in front of a phosphorus. No, because there's no hydro here. The only time you get to do that is when you see a hydro something acid. There is no hydro. It's phosphoric acid. So we know that this is a polyatomic ion because of that, because there's no hydro. We see it's an ic, and remember, ic replaces ate. So let's look for phosphate. Phosphate. Find it right here, phosphate. And for the most part, guys, these are in alphabetical order by the symbol, right? Not necessarily by the name, but by the symbol. It's in alphabetical order. So we got phosphate. This is PO4. This has a -3 charge. Okay, -3 charge. PO4 with a -3 charge. PO4. It's got a -3 charge, so I'm going to put 3 hydrogens in front of it.